All right, so this is the ISTA 130 midterm study guide we're going to go over. So let's just jump right into it, I guess. So the first thing it wants us to know is how to define a function. Of course, we kind of already know how to do this, but basically just as a recap, you would just type in def space and then your function name and then parentheses. And then if you have any parameters that you want to run your function in, and that the parameters will be whatever you're passing into the function whenever you run it. To call the function, you would just call the functions by typing in their name and then entering in whatever parameter you want to pass into the function. In this case, in these functions, I'm passing in a string here. So I'm literally defining what I want to pass into my function here. So for loops and while loops are a little bit of a different beast. So hang on. So with a for loop, when you do a for loop in Python, you always are iterating through a set list. Like you're iterating through a specific thing. So you know the end of your loop. There's always a definite end to your loop with a for loop. So you're saying, like, for example, if I have a list of like 3 items, if I say for item in list, then print item, what that's going to do is it's going to print every item in that list one after another. It's going to print each one on its own line specifically, and that's how that output would look. But the for loop has a definite end. When it gets to the end of that list, it's going to stop. That's the obvious part of how a for loop works. As far as a while loop goes, it may not necessarily have a definite end. You can define one with a definite end in a similar way by using like control variables. As you can see here, I have x is equal to 0, and then we define the length of the string that was passed in. And so while x is less than the string length, we're going to do stuff, and then we're going to add 1 to each iteration for x each time. So that's how we're going to control our length of our iterations. But theoretically, I could just write while true, then do whatever, and it will never actually get to the next iteration, or it'll never stop. Uh, it'll never stop iterating, at least one of the two, depending on what's in your loop. So that can definitely be, something to keep in mind. So in terms of what it's saying here, traversing by index, going down this list in terms of loops. So you want to know how to traverse a loop by index. So basically what that means is you're defining the index. So it's saying for I in range length string. So first of all, we're passing a string into this function. In this case, it was testing. So testing is 7 characters, it looks like. So this is going to be for I in range 7, print string I times 2. So what this is saying is for the index of string, we're going to multiply it by 2. So basically what this function does is every iteration, it's going to print the first, or well, on the first iteration, it's going to print the first letter of the string twice, and then it's going to stop and go to the next line, and then it's going to do the second letter twice, and the third letter twice, and the fourth letter twice, all the way until it gets to the 7th, and then it will stop after the 7th letter. So what this is basically trying to say is, because the length of the string is 7 in this case, it's saying for I in range 0 to 7. So it's going to iterate 7 times from 0 to 1 to 2 to 3 to 4 to 5 and to 6. So it's 7 total times because it starts at 0. So for I in range, so since what I represents here is the index, and specifically I represents the index of the string. So each string could have its own index. So a string is just kind of like a list of characters all mushed together. So if you think about the word word, for example, it's a list of 4 letters, WORD. And so the first letter in that, the first like item in that list, quote unquote, is W. So remember that indexes start at 0. So the count of like your index, like the value of your index, is going to start at 0. So when I say string I here, what I'm actually writing in that first iteration is string 0. So every iteration, this I is changing. So it's going I, 1, 2, 3, 4, and so on and so forth, each iteration. And that's perfectly fine. We don't need to say I plus 1 or I minus 1 or whatever here, because it's following the conventions of the index of the string. So because the index of the string starts at 0, then that's perfectly fine. Because if you were to say, give me the first letter of word, how you would write that in Python is you would say like string equals word. Let's just define a variable here. If I want to get the first letter of that string, all I have to do is write string with brackets and then a 0, because remember that the index starts at 0 and the last letter would be 3. So it's 0, 1, 2, and 3. So it's kind of a little bit backwards from like what you would think as a human reading it, because you would say, oh, the first letter is 1. So I'll just write string bracket 1. But actually the index starts at 0. So that's why this matters. And the index actually changes in each iteration. Python already knows to adjust this index after each iteration. It already knows to add 1 to it, because Python, that's how Python keeps track of where it is in a loop. It uses its own index. So unlike the while loop here, we don't have to do like I plus 1 after each iteration. In fact, I think we could, and maybe Python would just ignore it. But if Python doesn't ignore it, you would actually skip an iteration, and you wouldn't want to do that. In fact, we can actually do that right now, and let's see what happens, because I actually don't know myself, so it's always good to test things. So this is our third. So yeah, it looks like it's okay. It looks like Python kind of ignored. So Python doesn't add its own I plus 1 if you add it manually there. But you don't have to do that, because see, notice this is testing, but notice if I run this again, it's the same exact thing. So it really doesn't matter if I add that or not. So Python just ignores it if you put I plus 1. So we don't have to do I plus 1, unlike the while loop where we have to make a control variable ourselves. So that's the key difference between a while loop and a for loop in that way, is that you don't have to make a control variable because you already have a control variable with the I with the index. And that's what the I kind of stands for, is index here. So it's perfectly fine. Okay, so moving on to the next thing. So building a string just means that we are contributing to a string. So if I say like string is equal to word, and then this is a bad variable name, but bear with me here. And then I have another string that is a word, then I can just say new string is equal to string plus string 2, and I can say print new string, and that will give me word as a word, right? But I could also just say string, and I could use the join function as well. So there's other ways of concatenating strings. And then I can also say, for example, like I could also just do this. I could just say, instead of printing that variable, I can just do it within the function itself. I can just do string plus string 2. And that's one way of doing it. It'll give me the exact same output. Another way of doing that is you could say, you could put an empty string here, and you can say this, you can use brackets, and you can format that and say string 1 and then string 2. And oddly enough, that'll give you the exact same output. Notice I didn't have to put a bracket or a space between the brackets because there's already a space in this string. If there wasn't though, then you would have to add that in. So you would just put that here, and then, there you go. Okay, so that's what they mean by building a string. In the sense of loops though, because they're talking about under the loop section, what they really mean here is we're building strings in a loop. So what this basically means is taking an empty string or an existing string and adding to it or subtracting to it or multiplying or dividing things in the string and things like that. So that's all they mean by building a string. So it's in the same thing that we're doing here actually, where we're saying, and this maybe is a better example using this, each element of the string we're multiplying by 2. So we're building a new string based on that. Because basically every time we run this script, each line is its own string. So we're building a new string from the original string that we passed. And you could combine all these into one. So you could make this spell this out without having a new line between them all if you theoretically wanted to. And that would be also building a string. So that's kind of what they mean by that. Accumulating a sum, I think what it's referring to when it's talking about this is it's saying that you have a score or like some kind of value and you're adding to it each time. Then the best example I can give for this is the play turn example. So in this case, I used a list to this, but you could just theoretically just have a 0 and plus equals to that every time. So in this case, when you roll the dice, it creates a new element in the list. So if I roll a 6, it's going to put a 6 here. And then if I roll a 5, it's going to put a 5 here. If I roll a 2, it's going to put a 2 here. And then if I roll a 3, it's going to put a 3 here. And so what it's going to do, this part of this function is saying, this part of this function is saying, okay, I want you to add up everything in that list, and that will be our new score value. And so in this case, it would be, let's see, 6, 11, 13, 16. So this new score value would equal 16. It would be an integer of 16. So that's basically what they mean by accumulating a sum. There's two ways of doing this. You can either do like I did, where you create a list and store all your values and then just sum it at the end of your turn. Or you could just say, for example, equals 0. And then instead of appending to the list, all you would have to do is just say like score plus equals integer roll. So I just have to literally change like a few words in this line here. And I can say plus equals integer roll right there. And then I don't have to do this. I can literally just say score for this turn equals that. And then I can just get rid of that and just replace that return function. But I'm not going to do that because I already have this code here, but that's another way of doing it. So that's another way of like keeping track of your sum basically. So the last part of this is converting between for loops and while loops. So for loops and while loops is basically what I was saying before. For loops have a definite end and while loops don't always have a definite end. And the best place to use each one is I would use a for loop if you're going to be iterating through a specific set list of things. And I would use a while loop if you're just kind of iterating and waiting for a condition to pass. So imagine you are using a Python script to look through a list of like files on a computer, and you're trying to find a file that contains a specific thing. Like I want to look through a bunch of text files or a bunch of spreadsheets and figure out if there's a specific string in that spreadsheet. Like maybe I'm looking for a profit and loss spreadsheet for like accounting, and let's say I'm really good with my spreadsheets and I only ever write the words profit and loss on my actual profit and loss spreadsheet. Or maybe I just want to find every spreadsheet that contains the words profit and loss. So for like a report, for example. So a for loop would be pretty good because you have a definite end of files. So, it's like, when your files start and end. So it's like you just want to iterate through your current set of files right now as of running that code. You don't care about if someone goes in and adds a new file that contains it. You just want to look through your current list as of right now. And that can be okay. So that's a good example of when you'd want to use a for loop. And then, you can just iterate through that. A while loop, on the other hand, is better for if conditions need to be met, but maybe aren't met immediately. So for example, in the game Pig, where we were running the dice game, there is a specific set of conditions that may not happen at a specific set of time. So for example, the player rolls a die, but then they can choose whether they want to roll or not roll. So basically you're just waiting for them to say, okay, I don't want to roll anymore. And that's not a specific iteration. You're not iterating through like 10 rolls or 7 rolls or whatever. You're doing it until the person says, okay, I'm done. So that's a good example of when to use a while loop, because those loops just run forever, basically, until a condition is finally set. Now, in a for loop, you could theoretically do something similar where it's like, okay, I'm looking through a list of items, but when I find a list of, like, when I find the thing that meets my condition, then I'm going to stop the list. Yeah, you can do that, but you're still iterating through a set list of things. So that's where you'd want to use a for loop versus a while loop. And to convert a while loop kind of into a for loop, a good example of this is looking at the traversing by strings function that we had here, or the program, I mean. So notice that in a while loop, we don't necessarily have a definite end, like I was saying. So this is where you want to use things like control variables or like specific logic, like math, to kind of help you out here. So in this case, I defined x is equal to 0 outside of the loop, so that every time we run this loop, we don't say x is equal to 0, because then we'd have an infinite loop. So x is equal to 0. I use this as my control variable. So, and then I define the length of the string as a specific set. In this case, I think it was like 7 or 8 or something, 7 or 8 letters long or something like that. So we know that this is 7 letters long. So, so basically every time this function is running, every time this while loop runs, it's going to say, okay, what's the current value of x? And is it less than the 7? Because that's what the string we passed into it was. But we could pass any string into this, but the string we passed in was a 7-letter string. So, you know, going physically by what it's actually looking at, that's what it's saying. So is 0 less than 7? Yes. Okay, do this stuff and then add 1. Okay, is 1 less than 7? Yes. Okay, do this stuff, add 1. Is 2 less than 7? Okay, do this stuff, add 1. And what's going to happen is when it gets to 6, it's going to do this. It's going to add 1. It's going to come back here. And well, it won't go all the way back up here, but it'll go to the while part again. So it'll go here and then back up here each time. And then when it gets to 7, it's going to say, is 7 less than 7? No, because it's equal to 7. So don't do any of this, just break, and it stops. And it just skips these 3 lines of code and it goes to the next stuff, which in this case, it's being actually ran in the main function. So when it skips, it's just gonna, you know, it would be here and then it would stop. And so that's the end of the program. But if I had more functions down here, it would go on to the next functions, basically. So that's how you convert a for or a while loop into a for loop. So let's move on here. So the next part is talking about creating and evaluating arithmetic, Boolean, and string expressions and combinations thereof. So basically what the creating part means is just how do you create a variable? We all know how to create variables at this point. It's pretty obvious. Like if you've gotten this far in the class, you should know how to create variables, because it's just, for example, here I made a string variable, and then I could make an integer variable, which is just a number. And then I can use a float variable, which I need to write this as some other convention so Python doesn't yell at me. But floating variable is equal to 0.0. Notice there's a decimal there. And floating points are actually a little bit more complicated than it seems. But we'll leave it at that level because you don't need to know quite more than that. So we'll just leave it at that. But yeah, basically just think of integer plus decimal. That's what a floating is. I mean, that's the simplest way of explaining it. And then Boolean variable is going to be equal to true or false. Pretty straightforward. We can just literally write that out because you can ignore the or here. I'm just writing it just to show you both options. So it's either true or false. So those are your variables in Python. That's how you create them. In terms of evaluating them. So actually, let me not get rid of all those because I want to show you something. So how to evaluate a variable. So any variable in Python is evaluated a little bit differently based on its type. So strings are evaluated as true if they contain something. So I'm going to make some new variables here to show you what I mean. So that's what a string would look like if it was going to evaluate to true. If the string evaluates to false, that means that it's an empty string. So if I'm debugging my code or testing my code and I want to make an like some kind of if statement to say like if string true, then print string true. I can do that. And what it, well, actually, let me make sure I actually run my code. Then it will print word, right? because this is true. But if not, which means if not true, then don't do that. So because this string isn't empty, it's not actually going to print anything because it's not an empty string. But if I use the false here, if I say if string false, then it's also not going to print because that's false. But I could say on the flip side, if not, then it will print. Because basically what you're saying is, and what I mean by the if and if not thing is when I'm writing if and if not, what I'm saying is if string is equal to true, then do something. And we know that it's not. We know that this is false. So, but if I write if equal to false, then it will do stuff, right? Well, in this case, I didn't write it properly because, but anyway, you get what I'm trying to say. So that's kind of what I mean by the if and if not thing. And so that's when a string evaluates a true or false. Basically, it's all you really need to know. You don't have to worry about the if or if not stuff, but basically just know that if a string contains literally anything other than being empty, then it will evaluate to true. If not, it'll evaluate to false. Integers, on the other hand, are quite interesting, actually. Integers will evaluate to true if they are anything but 0. So, for example, 1. But if they are 0, they'll evaluate to false. So I can say in that same right, if integer, which actually I don't really need to make these variables because I can just use the same variable to show you what I mean. So let's just do that. That'll be a little bit cleaner and easier to explain and a little less to like think about. But so I could say if integer, then print hello world. So what's going to happen when I run this code is it's actually not going to print anything because it's false. So we're saying if the integer is true, then print hello world. It's not true. It's actually 0. But if I change this to like 5, for example, I can run it and it'll print hello world. That's how you evaluate variables. That's what it means when it's saying if it's true or false. So that's how to evaluate what a variable's value is when it comes to integers and strings. Floating points, I think, are the same situation, but let's test it just to be safe because I don't want to give you guys the wrong information. But I'm pretty sure floating points are exactly the same. So we can say if float variable print hello world, and I think it will not print, but I think if we just change this to like literally anything else, it should print. Yeah. Even if it's 0 point something, it doesn't matter. As long as it's not 0.0, it'll do whatever. And I can add like a million zeros here and it will still not do anything. It has to have at least some number that's not 0 in there. And that's how floating point variables evaluate to true or false. So same thing as integers, it's just you have a decimal. But the first value doesn't matter. It's just somewhere in that number, there has to be a number somewhere. Like somewhere there has to be a non-zero number to be true. Otherwise, it's false. The Boolean values are pretty freaking straightforward. I literally cannot be any more obvious about this because it literally explains it because the Boolean values are literally true or false. So I can literally just say Boolean variable. If Boolean variable equals true, and I can write it like this so it makes a little more sense, then print the Boolean variable, right? And it's going to print true. But I could say if equals false, it's not going to print anything. But if I change this to false, then it will print. That's kind of what I mean. And that's what I'm writing when I'm saying if or if not. Because if I change this, I can just change this to if not. And it should evaluate to the same thing. Yeah, that's what I mean by if and if not. You're basically saying if you write if not variable, then what you're writing is if variable is equal to false. This might be easier for you to read and understand, but it's not exactly the most clean way of writing code. So just keep that in mind, but you don't have to worry about that. Okay, so that's how you evaluate variables in Python. So let's move on here. So create conditional statements. So we kind of already talked about this. We sort of touched on this earlier, but let's write a function here and let's just call it def function because I'm lazy with my variable names right now. So we're going to say in this function, we're going to take two numbers, number 1 and number 2. Pretty obvious names here. So in this function, we're going to say if number 1 is greater than 0, then multiply number 1 times number 2. If number 2, if number 1 is less than 0, then number 1 times number 2 times number 1. And then else number 1 is equal to 0, number 2 is equal to 0. Okay, so I'm going to use this to highlight something that's really important here. Let's just do that actually. Okay, so I'm going to use this to highlight something. So let me just finish writing this one last bit of code, and then I will show you guys. Okay, so let's try this with a few different parameters. So this is going to be 1 and 5. This is going to be -1 and 5. And this is going to be 0 and 10. So it's a little bit easier to understand. Okay. So this is what happens when you run these. So, I guess let me just, sorry, let me change this so it's a little bit easier to understand what's going on. So basically to evaluate if, elif, and else, what you're doing is we're basically saying, okay, so what is an if statement? What is an elif statement? What is an else statement? So an if statement is you're basically setting a conditional statement. So you're saying if something, then do something else, right? That one's kind of obvious. It's kind of easy to understand what an if statement is saying because it's kind of plain. But elif is a little bit more complicated to look at. When you're looking at it, you're kind of like, what the heck is elif? So elif is literally short for else if. And what it means is you're basically adding a second if statement that doesn't confuse Python. And you're adding it in the same like indentation as the original if statement. So in this case, what I did was I said, okay, if the first number that you run with this function is greater than 1, or sorry, greater than 0, then we're going to multiply these numbers. But if it's less than 0, we're going to do the same thing, which is a little bit confusing. So let's just say like, I don't know, minus here, just so it's a little more obvious. So in this case, we're saying, okay, if the number is less than 0, then we're just going to subtract the numbers that we gave. And then what else is saying is if it's literally anything else, which in this case, it can only be if the number is equal to 0, because that's the only other possible like case. But this may not be the best example to give, but if you were using something like some kind of if statement where there could be many possible values for your variable, and you want to like control, like for example, if you're asking someone a yes or no question and input, you want to be able to control what they say. So I'll give you a quick example here. So roll again. So in this case, it's saying like, I'm going to ask the user if they want to roll the dice again. If they say yes, then I'm going to return true. If they say false, or sorry, if they say no, I'm going to return false. But if they say anything other than yes or no, in this case, Y or N, I'm going to say, hey, I don't understand what the heck you just told me. Please give me a Y or an N. So this is important because sometimes you need them to say like a very specific thing. So this is a good example of when you would want to use the if, elif, and else statement. So that's where you can use those at. So we'll kind of move on just for the sake of time, but that's basically it. Okay, so moving on. Print and input, pretty obvious. Printing is just printing stuff. So you're printing out like things to the console, and we'll kind of keep it at that for now. Inputting is just you're going to type a prompt here. In this case, you can forget about the format thing. Just forget the brackets and the format. But basically, you're typing out a prompt for the person to respond to, and then they can type whatever they want. You can store that as a variable, and then you can do things with that based on what they typed. Or you can not store it as a variable, and you can just say like press enter to continue, for example. And like here where I say, okay, press the enter key to continue. And the user could theoretically type a bunch of gibberish and press enter and it still won't even matter because we're not actually doing anything with that value. So that's the input function. Note that the input function only takes one argument, which means that you can only put one thing. You can't separate anything by commas here or whatever. You can only put one thing. So like one string here or whatever. So that's kind of important. Okay. So indexing a string. So we already talked about this, so I'm going to kind of skip this, but basically what it means is, for example, this word, well, I kind of got rid of it, but we'll say like string is equal to word. So basically what this is talking about is if I say print string 1, it's going to print the word O or the letter O because that's the second. So if I say print string 0, it's going to print W. And if I say print string 2, it's going to print R. And if I say print string 3, it's going to print D, because that's how you index a string. Index starts at 0. So this is 0, 1, 2, 3. And that's how you index a string. That's what they mean by that. So let's kind of keep going here in this PDF document here. So it's saying know how to document a function. So I'm a little bit kind of OCD about my documentation. I'm very like particular. I'm very over the top and thorough with my documentation. I don't think you have to be as thorough as me, but this is how you document a string basically. So in this case, I write what the string does. And in this particular case, I actually showed what the output will look like because I felt extra in that day. But you don't have to necessarily do that, I guess, if you don't want to, but know how to document a string. So like in the first part of your string, you're going to put little quotes and maybe single quotes or double quotes. And this is called a doc string. And what you're doing is you're documenting stuff but with a giant string. And that's why it's called a doc string. So in this case, I'm writing like this function traverses strings by element and prints that element twice throughout each iteration. That's all you have to leave. You just have to write that. And in this case, it's a really simple function. So I don't have to write like 10-page documents on how every part of it works, So it's a really simple function. So I could literally just write one sentence. Like if you write 1 or 2 sentences on how it works, just a super like explain like I'm 5 kind of way, that's what you want to do. On the next part, you put your parameters. So in this part, you're not really like the best way to explain the parameter part is just write what you want the user to input as a parameter. That's the best way to write documentation here because you want to write like for example, in this case, I put parameter string and I said, just put any string you want here. And then I said, what will happen to that string? But this part is kind of like, you don't necessarily need this part because that's kind of explained up here basically. So this is kind of redundant, but yeah, in this case, I just put any string you want. That's what I said. But if there's a specific, like if you are saying like, if this was an integer and you wanted to enforce that that's an integer, there's ways of doing that in Python. You can like set specific types up in this, like you can, I don't remember how you actually do it, but there's a way you can like enforce, I could say like type string here after this, and it enforces that this has to be a string. But you can also just put it in like plain documentation, like, hey, if you're going to use this, make it a string, otherwise you'll get errors, So that's basically what you're doing in this param string line. And you do this for all your parameters. So if I have like 5 parameters, I have to make 5 lines for this. But you can just keep it simple. You don't have to write like 10 pages about this stuff. And then the return, you just have to write what the function returns. And so if you're printing something, but you're not actually, since I don't actually say like return here, I don't have to write returns anything because it just returns none. It's not actually returning anything. So I'm just going to write returns none. But if I wrote a function that actually does return something, in this case, for example, my roll again, I can say returns true or false, depending on whether they want to roll again. And that's literally what I wrote. And I think there's maybe a cleaner way of writing that, but that's how I do it. I'm not saying that's the best way. I'm just saying that's how I do it. But that's kind of what it's talking about, basically. And I've gotten good grades on my documentation so far. So I don't know. Maybe I'm not the best example, but it's worked for me. So I don't know. Just when in doubt, just maybe be a little more thorough with your documentation rather than not enough, I guess. If you have to. I mean, obviously clean code kind of speaks for itself, but if you have to, whatever. Okay, so we're going to kind of skip ahead here for time. So the next part was knowing how to evaluate arithmetic. This is the order of operations. So I'm going to let you guys kind of read about this. We won't go over it too much, but basically these are what these, you just have to know, like we all know what a plus sign does and what a minus sign and asterisks do. It's just multiplying. The slash is dividing, and these are your divisors and stuff like that. And this is your exponent is the two asterisks. So I'm not going to go super deep into these because, you know, we'll kind of skip over this a little bit, but just if you need to just read, like you can kind of Google this and see like what's the order of operations and what are these operators, and just look up like Python operators. It's pretty self-explanatory. It's easy to find information about this stuff. I'm mainly just going over the conceptual stuff right now because it's not quite as easy to look that stuff up. So that's what I'm going to spend most of my time on. I don't want to waste your guys' time too much. So the next thing is the number of squares. So this is what it's saying, like know how to evaluate Boolean expressions. And so what this means is this is saying take this value plus this value and then create a sum of that. So that's going to be a new total value here. So if this is 1 and this is 2, then this in parentheses would be like 3. And then 3 divided by this other value, is that less than or equal to 40? And if it is less than or equal to 40, then we're going to, this is going to evaluate to true. If it's not, this is going to evaluate to false. So basically what this is saying is, if I say number 1 is equal to 1 and number 2 is equal to 2, actually, let's make this clean math here. So let's say 5 and 5 and 5. And then number 3 is going to be equal to 2. So if I say total equals number 1 plus number 2 parentheses divided by number 3, then I can just say if total print hello world. And it's going to be, it's not going to, it's like, it should print because I'm saying like if this, oh wait, sorry, I didn't add my, whoops, I'm an idiot. There we go. Sorry guys. Whoops. Okay. So yeah, it'll print hello world because it is actually less than or equal to 40. But if this was like 500 by 500 or something, it shouldn't print. So that's all it's saying. We don't need to write if this is less than 40. We don't need to say if total less than or equal to 40 or whatever. We don't even need to use an if statement because this evaluates to true. Remember what I was saying? Because I was saying like if total is equal to true is what we just did when we said if total, right? So print hello world. So we don't need to use an if statement for this particular part because this evaluates to true, right? So that's what you're basically saying is you don't necessarily need an if to evaluate this. I'm just using this so you can see like that it actually does. But if I were to just like get rid of this line of code here and pull out my debugger here, I can just debug this and then I can say true. See, it shows it's true. But if I change these values to like 500, as we saw, it'll show false here. So we know this evaluates to true. So that's what it's saying here. Okay, so let's move on. So we're going to kind of skip ahead here, moving on. understand the logical operators and their precedence. So this is not and or, and not goes first, and goes second, or goes third. And that's how you create compound Booleans. So I can say total is equal to true and false would go second. But if I said total is equal to true, not false, that would be, that would go first. And then true or false would go last. So true, not false would go first. Whoops. This would be first. This would be second. This would be last. That's what they mean by the order. As far as like how to like know the logic and how they evaluate, I think I know what it's saying basically. But I'm going to leave that open. I'm going to ask the professor about that to give, or like we can look up a little bit more about this later at the end if we have more time, so we can kind of explain this better. But for the sake of time, I'm going to go ahead and skip over this and we can come back to it. If any of you guys know a little bit more about what it means, I guess it just means like evaluating statements. Like if a statement says if something is true and something else is true, or if something else is true, then do this. I guess that's what it means. But I don't feel 100% comfortable on explaining it the best. So I'm going to skip it for now, and then we can come back to this and research it later. And I'll just post like in the comments, like what I found after I research it. So I'm not sitting here Googling things and trying to explain things to you for like 30 minutes. Okay, so moving on. So know what happens when a value is used in a condition. So know what values of X are, and if the statements, we're going to skip this because I already did this like 50 times now. But yeah, if I say like if number 1 is equal to, or if it's true, then print high, like it's going to print because it's not 0. But if this was 0, it's not going to print. So we're just empty, basically. That's what they mean by that. So if something is true, then do something. If not, then don't do something. Okay, and then this is saying, it's saying be able to evaluate this expression. And so we're going to say like, if we change number 3 here to be, or actually, let's just say, let's get rid of these. And let's just change this to 9. So if we say number 1 divided by 3 minus number 1 with the divisor of 3. So I can just say print. And that will evaluate to 0.0 because you're basically saying 9 divided by 3 minus 9 with the divisible by 3 kind of divisor. And this is just going to evaluate to 0 because it's 3 minus 3. So it's just going to be 0. In this case, it's 0.0 because one of these gives the actual decimal value. And that's why it shows that. So that's why that evaluates to that. It's just the order of operations because it's the PEMDAS thing that we talked about earlier where division goes first and then subtraction will go second, basically. Okay, so kind of skipping ahead here. So know how to create and evaluate string expressions using concatenation, repetition, and indexing. We kind of already talked about this, so I'm not going to go back over it. Know the length function for strings. So if I say like string is equal to word, I create a new string variable here. If I say print length of string, what it's actually going to do is print me 4, not the word because I didn't print the word, but it's going to print me 4. And that's because we're using the length function to figure out how long that string is, basically. So moving on. So know that string literals are always enclosed in quotes with the exception of user input. Yep, okay. Make sure you know how to distinguish between a variable name and a string literal. So in this case, the part where it says word here is a string literal, and this is the variable of it. And I can say like stuff equals true, and stuff and true are not literals. Well, they're not string literals. I mean, this part is a literal because it says quote word, right? But this is a Boolean variable, so it doesn't count. But these are variables. Stuff and string are variables, and the part where it says word is a string literal, basically. And I actually posted about this in Slack. So Quan actually responded to me with a little bit more information about it. So if you want to read more about it, you can look in there, basically. Okay. So, sorry, guys. So moving on. So know what an empty string and its literal is in Python. Yep, we talked about empty strings and stuff before. Know how to do string repetition and concatenation. Concatenation just means adding to a string. So I can say string 1 equals word and string 2 equals is a word like I was showing before. And then I can just say print string 1 plus string 2. And that's going to print word as a word like we show here. So that's what you mean by concatenating strings. It's just adding strings and when you're adding strings, you're kind of like joining them together. So it's kind of like me saying string 3 is equal to word is a word. So you're kind of like losing this quote and this quote as if they didn't exist. And you're kind of putting that all in one string. So basically this is the exact same thing as me saying string 3, print string 3. It's just going to print the same thing. Notice they're exactly the same. That's what we're doing. So that's what it means by string concatenation. Repetition just means like printing the string over and over or multiplying the string. So I could say string 2 is equal to word. Let me add a space so it's a little more readable. String 1 times 5. And then I can say print string 2. And if I do that, it'll print word, you know, so it's just multiplying the string. So you're repeating the string over and over, and you can do that in loops and other stuff. So as we've seen already, so I won't go too deep into that because you kind of have already seen it at this point. So we'll kind of move on. Okay, know that the input function always returns a string. So what that means is if I say input, and actually let's create this as a variable. So let's say input variable is equal to, and this isn't a good variable name, but I'm kind of skipping over that right now for the sake of time. But input give me a number between 1 and 10. Now, ideally, you'd put an actual like if statement here to say if number is between 1 and 10, then sure, but if not, then whatever. But we're not going to do that for right now. And then we're just going to say print input variable. I guess just for the sake of like simplicity, we'll just say give me a number because that's easier. So what's going to happen here is if I run this code and then I type in 5, what's going to happen is if I actually evaluate this, see if you look closely, this is a string. It says string 5. This isn't actually a number. So this is going to be really interesting. If I run this code, like let's say I want to do something with that number. Let's say I want to say, okay, whatever your number is, multiply it by 50. So I'm going to say like, well, that might be kind of a big number, but you'll get what I mean. So we'll say like, we'll just say new number is equal to input variable times 5. Let's just say multiply by 5. Okay. So what's going to happen is if I print new number here, this is going to be pretty interesting. Watch what happens. If I run this code and I put in 3 or 2, actually, it's going to print 2 5 times. It should have gave me 10. Why did it give me 2 5 times? Well, it's because it's a string. If you multiply a string by anything, it's just going to repeat that string and then kind of combine that all into one string. So that's why it gave me that. So what you might want to do in this case is you might want to wrap this in an int function so that you can tell Python, okay, whatever number they gave me, convert that to an int. So now if I do this, it should give me 10, right? So that's important. That's what it means by that. Okay. So let's go ahead and move on. Oh, where it said input can take no arguments. Basically what this means is you can clear all this crap and you can just do an input function. And I'll just say print hello world here or something. and we can ignore the string variable for now. So what's going to happen is if I use no arguments here, if I don't put anything in the input quotes, it's not going to give me any prompt. So the user might just think, oh, the program's like running or something, like it's blinking, it's running, it's loading or something. But actually all you have to do is just, like, you can sit here and type all day and it'll never do anything. But if you just hit enter, it'll print hello world. So that's what it means by it takes no arguments. Theoretically, you don't have to give someone a prompt, but I kind of don't like that because it, like, I guess in some ways it could be helpful, but it's kind of like it can be misleading and confusing for users, but that's what that means. Okay, moving on for the sake of time. So know your escape characters, at least /n and /t. So basically what this means is in any string, excuse me, in any string, you can put a /n and you can say word is a word. And what this will do is let me just print string 1 so you can actually see it. So what this will do is it'll print word is a word. And of course there's a space after that. So if you don't want a space, you just don't put a space after /n. And if you don't want a space after word, you can do that too. It won't notice any, like, you won't see any difference at first glance. But if I put a space here, there's actually a space after word. So you can see it there. And then the /t is the same thing, except instead of a new line, you're just adding a tab. So it's going to look kind of weird. You're adding 4 spaces. In this case, there's also a space after this. So there's actually 5 spaces. So, whoops. So in this case, there's 4 spaces. So if we count, which we can't really do, but it'd be 1, 2, 3, 4, and then you get to is. So that's kind of what those escape keys are. So let's move on here. Understand how the print function works. Know that it can take multiple arguments. So basically what it means is I can say print hi, my name is Logan, right? And then it'll print all those things. And that's what it means by it can take multiple arguments. So this is an argument, this is an argument, and this is an argument. But you could just type like, hi, my name is Logan, or in this case, for the sake of time, just hi. And that works too. Or you can just print nothing, but if you print nothing, it will still print something. It'll print a new line here by default. So if you just do print without an argument, it'll just print a new line. Okay, understand what happens when you print a string variable concatenated in multiple strings. Yeah, we kind of already went over this, so I'm going to skip this. For both input and string or print, watch out for missing parentheses. So yeah, if I write a print here, but I get rid of the parentheses, Python is going to yell at me. It's giving me like errors up here. It's saying like, hey, what the heck, man? I'm expecting more, so that's what's up. Notice the difference between, or know the difference between print and return. This is actually kind of important. So if I say like def function is equal to, this stuff. So if I say print, let's give a variable here. Let's say x is equal to 4. And then I say print x. What's actually happening is if I run this function, it's going to say 4. And that's fine if that's all we want to know. But let's say we want to do something with x. Let's say we have another function here and we say def function 2. Again, very bad names, but just for the sake of time, let's just ignore that for now. So let's say y is equal to x times 4. See, the thing is, and let's actually use a different variable. Let's just say z. So the thing is, it doesn't know, like, I can't just run this function unless I call the function. So like, for example, I can call function here, and let's just use a different number so it's a little bit easier to see what's going on. So I can just do like 5. So the thing is, I can call this function. I can say function 2, and then I can put any number I want, like 6 or 56 or 7 or 8 or 9 or 10 or whatever. But the thing is, I can't call in x. If I try to call in x here, Python's going to yell at me. You can see it's highlighted in red if you look closely. What's going to happen is it's going to say x isn't defined because I'm not returning the value of x. I'm also not defining what x is. So in this case, instead of printing it, I mean, yeah, I can print it, that's fine, but I need to also return x. And then what I need to do is I need to say x is equal to function. Now, if I do this, it'll work. It'll give me 4 and it'll give me 20. So In this case, I defined X twice, which you may not necessarily want to do. You could just say, for the sake of, whatever, I can just write number and then number and then number, right? So number is equal to 4. And so in this case, it does the same thing. It doesn't actually change anything. So I don't want you to be confused by the X and X here. But yeah, so number and then X. So this is what this means when it says, like, be careful about what printing versus returning is, because printing is fine. Like, yeah, I have the 4 here, but I can't do anything with that 4 unless I return that, and then I can define that as something, right? And you can actually return multiple things and get multiple you can define multiple variables in one line, but we won't go over that because it's a little bit too much for right now. But that's basically what this means. Okay, moving on. So know how to save the value a function returns when called into a variable. Yeah, I think that's what I literally just went over, where I was like, where I said X is equal to the return value here of this function. So we're calling this function with no arguments, and this function just says 4. So we're printing the number. We don't even have to do this if we want. And we can just say number is 4, return number. We don't even have to do this. We could literally just do return 4 if we wanted to. And now X is equal to that 4. So whatever you're saying return here, that's what your variable, like if you're defining a variable as X is equal to calling the function, what you're basically saying, what you're telling Python in this line is you're saying, okay, I want X to be equal to whatever this returns. And you could return multiple things. Like you could say, if number is greater than 0, return true. If number is greater than or less than 0, return false. And then X is just going to be true or false. It just depends on whatever condition you have. Like this is a better example because I could say, like, if Y is greater than 0, return true, because this depends on what Z is, right? It's kind of dependent on whatever the Z value is. I could put -5 here, and this would be -25. So it could return false if it's less than 0 because it's -25, or it could return true if it's just 25 because it's higher than 0. Does that make sense? So you're defining X is dependent on whatever's going on in your function because you're returning something. In this case, X will always just be 4 because I'm not doing anything specific, but this might be a better function example because you could do stuff with this. Like you can give, like someone can input a number when they run it. So that's kind of what I mean. Like I don't have to do 4 here. I could do like 7 and it would give me a different like variable like value here. So I don't have to use X. I could do something else. But I'm using X in this case to highlight that. Okay, so moving on. Whoops. Sorry, guys. Okay, know how to incorporate the random function. So I could say import random, and then I could say number. Well, I don't even have to make a variable for it. I can just say print random.randint 1 through 5, and it'll give me a number between 1 and 5. In this case, it gave me 5. This time it'll give me 4. This time it'll give me 4. This time it'll give me 4. This time it'll give me 5 and 2. So you're just printing like a random integer based on that. And basically, by the way, what you're telling Python is you're saying, okay, from this random module or random object, run the random function in this object. So this is the function that you're running, and this is the module you're running it from. That's why it's random dot. And if you ever import math, like for example, import math, and you do like pi is equal to math.py, and then you print pi, what you're saying is, okay, I want you to run the, like, look into the math folder, like the math module, and look for the pi function and give me the pi value, like whatever it returns. So like, for example, if it says like def pi return 3.14159, whatever, and then I could say like return pi, right? So I could say pi is equal to pi, literally. Then I can print pi, and it's kind of doing the same thing. That's what that function is doing in the math module. I mean, well, technically the math module is doing like actual math to calculate pi, but you know what I'm saying? Like that's kind of what it's doing. So that's what it means by that. Okay, moving on for the sake of time. Turtle will not be on the exam. Okay. Oh, I skipped a line. Understand conditional execution of code, if, elif, and else. writing code. We kind of already went over this. Understand indentation. You also have to be able to create Boolean expressions that define for execution. Know that else catches any other condition. Okay, yeah, we kind of talked about this. Be able to translate instructions given in English into Python. It's basically just saying know how to write code given instructions. So if we kind of know how to do that, I guess, depending on what it'll be. Be able to define functions given specifications about their functionality and parameters. As part of this, you'll have to understand Python indentation and know the function of definition syntax. So this is just saying know what a function looks like, and we do already. I mean, you can ignore this part of it, but we know that this is the part where you define a function. This is the part where you give the parameters that you want your person to use. This is the actual body of the function, what's going on in the function. And when we run that function, this is the like them calling the function, and this is the argument of what they're going to use for their parameter. And same thing for here and here as well. So let's see, know how to call functions, an argument, parameter processing, whatever, blah, blah, blah. Define a parameter, understand the benefits of a function. Yep, okay. All right, understand scope. So, okay, this is important. I don't think I went over this yet. So if you define a function, like say, for example, I have this X here in this function, right? I can't use that X elsewhere. We kind of talked about this earlier. Like if I try to say like Y is equal to X plus 5, it's going to yell at me and say, okay, well, we never defined what X is because X is here, and X, like if I try to run this code now, it's going to yell at me and say X is not defined. But theoretically though, if I ran this here, whoops, if I run this, oh, I guess I copied an empty line or something. But if I say y is equal to X plus 5, then it would give me a variable. Like I could print Y here. Of course, it might look weird because we already added 1 to it and it started at 0 and it's going to change every iteration. So it's going to look super weird. But yeah, we could run it here. But if I run it outside of that function, it's not going to work. So that's kind of important. Okay. So understand and be able to write for and while loops. Yep, kind of went over this. Know how to use a loop to update a variable. Yep, it's just like changing variables within a loop. Or like build a sum like we were talking about, like how we were doing the sum function over here and all that. Let's see. What is weird? So weird is just going to be DDDOOGGG, I think, because you're multiplying every time you're going. So weird is an empty string, but every time you're going through each letter of the string, you're multiplying it by 3. So it's going to be DDDOOOGGG. And that's going to be weird. Because you're basically saying for I in range, so you're saying every time we go through each letter, multiply it by 3, and you're going to add that to the string. So you're adding to an empty string that value, basically. Okay, so you should be able to look at the above code or above loop and know what it does. Yep, as we said, you should know what it's doing using an execution trace. Yep, know what a string variable indexed by an integer evaluates to. So remember the index starts at 0. So E is actually 0, and then L is 1, and E here is 2. So this would actually print out lowercase e. And I can show you that if I can copy it correctly. So this should print out lowercase e. Yep, that's what it gives you. Okay, know what the for and while loop control variables are. So control variables like I and all that, like how we said here, like mine is X here, but you can just imagine this X as an I, for example, and you can just say I is equal to 1, and while I is less than the length, then keep doing I stuff, and then I plus equals 1. So yeah. Know how to traverse by index and accessing dimensions of elements of a sequence in order. Yep. This is traversing by an index. It's just that X is instead of I, it's X, but it's doing the same thing. I probably should have just made this I for the sake of consistency and completeness with coding, but it's okay. So know what, oh, we already did that. Okay. Know how to convert for loops and while loops. Yep, we already talked about that. Know when to use while true and how to end such a loop. So actually, I'm not even gonna create a new loop. So let's just say, let's copy this. And let's get rid of our doc strings because it's kind of unnecessary for this right now. So let's just refactor that into an I. Okay. So basically, instead of using, so when you're using a while true loop, what you're going to do is you're just going to say, like, instead of doing this kind of loop, what you'd want to do is say def while true loop. Okay. And then I'm going to give you like a string thing. So we're going to say input, please give me a number. And then let's make it an integer just to be specific. And then we're going to say if int input equals is instance int print int input, else print, sorry, I don't. Okay, so if I run this function now, I can just ignore this. Oh, I never did the while thing. Whoops. Sorry, guys. I knew I was like, why is it yelling at me about continue and break? There we go. Okay, cool. So now if I run this code, what's going to happen is I'm going to give it an integer and it's going to print me out my integer, right? I think I did the is instance thing wrong. Let's just say, hang on. Oh, okay, that's what I did. I didn't give it a number to check. That's what I did. Let's try that. Hang on. Sorry, guys. I'm doing silly stuff here. Let's just create this as a variable. I think that would work. I'm kind of testing things on the fly for you guys. We're learning on the fly. Oh, it's not going to be an integer because it's a string. Whoops. I mean, this is kind of silly because this isn't really a good code because we're forcing it to be a string, so it's never not going to do this. So this is probably the worst example I could have gave. Okay, let's just do this. Let's create a different if statement. This will take me just like 2 seconds. So if int input is less than 0, print. Actually, let's just say greater than 0. Okay. So, whoops. Phone alarm going off. Okay, so now if I run this, I give it 5, it'll print me 5. But if I run this again, and if I give it a -5, it'll say, hey, give me an integer greater than 0, right? So the reason I'm doing this is to show you that this is how you would end a while true loop. You would just break or you would return something. So if you break or return int input, for example, then that's how you would end a while true loop. Continue just means start the loop from the beginning. So start all the way back up here, basically. And that's how you would do a while true loop. So you say while true, then do a bunch of stuff and then return or break. And depending on what you want to do, you can also just break and then return later. So this is another way of doing this. So you could just say like break and then write indented in the same line of your while true loop, return int input, right? And then I can say x is equal to that and then print x, right? It's going to print it twice because we already have a print function in there, but so we'll say 4. It's going to print 4 from the function, but then because we returned it at the end and then we defined it and then we're printing that, it's going to print 4 here too. Okay, so that's how all the stuff. You don't need to traverse by element. You don't need to worry about slicing. You don't need to worry about string methods, and you don't need to worry about nested loops. So that's going to do it for us, I think. I'm not going to make this any longer than it already is. But if you guys have any other specific questions, I'll try to get back to you on the other stuff that we glossed over here. But if you have any other specific questions, just feel free to comment or let me know about it, and we'll kind of go from there. I'll try to help out as much as I can. Okay. All right. I'll see you guys later. Thank you so much for watching, and good luck on your midterm.